Here we are in 7.3, and 7.3 is going to introduce us to the law of cosines. So if you remember, we have some situations in which we are able to use the law of cosines, and that law of cosines is going to be used anytime we're unable to get the angle that's directly opposite a side that we know. And so when we're not able to do that, we're going to be using the law of cosines. So it says in any triangle ABCs with sides A, B, and C, the following hold. A squared is equal to B squared plus C squared minus 2BC cosine A. And you can see that derived in the book. I've chosen not to just go through the derivation process, but it is related to some similar work that we were doing last time when we were drawing the the perpendicular down and creating right triangles. So let's look at this example right here, example 2, in which we are trying to determine whether we're going to use the law of sines or cosines. My suggestion to you is when you do that, have an arbitrary triangle in mind, right? So we'll let this be A, B, and C. So this would be little a, little b, little c. And let's see what we know. In this one, we know two sides and an angle. Well, let's see what we have. I'll go through and we'll highlight. In that very first one, we know side A, side B, and angle C, right? That angle right in there. Is that enough? Do we know the side opposite? Could we figure that out? And we don't. We don't have enough to figure out what B and what C is. And so, what angle B and angle A are. So we're never going to be able to use the law of sines because I'm not going to, with the given side B, I'm not able to determine what the angle B is. And with the given side A, I'm not able to determine what angle A is. And so this is the law of cosines, right? And what is this? This is side. If we look at it, this was side, angle, side. Now you could go through memorizing side angle side is cosines and side angle is sines, or you could just keep drawing yourself a picture. So let's come back in here and see what we're given with number 2. In number 2, I know angle A. Whoops. Apologize. I know angle A. I know angle C, and I know little c. So I know an angle and the side opposite, no problem. For sure, this is sines. And I can unlock everything with that. And they're asking us to determine whether it's which one of these it is. This is side, angle, right? Do we have that? Yeah, the very first one, side, angle coming through. What about the next one? And we're just going to go through these just one by one, ideally pretty quickly, right? Little c, capital C. Okay, side A, side B, and angle A. What is that? That's angle side, or side angle, right? It could be side angle. And so that's what they'd have because the angle is not included. And that definitely is sines. Now, how do I know that? Not by memorizing side angles, but by seeing that there's a directly across relationship there in which you know both elements. And so you're going to hopefully be able to use the law of sines first. We know in this one A, we know B, and we know C. So that's angle side angle. But anytime you're given two angles, you can figure out the third. So this is the law of sines. And so angle side angle. This is going to be the next one. What do we got there? We got a couple of angles. Come in here and circle. Angle, and the side in between them. So this is angle, side angle. But again, you know 2. So this has to be the law of sines. And then with the next one, ACA. So A, sorry about that. A, little c, A. So that's side angle. but we do know the angle across, and so this is the law of sines, right? Because we know this connection here. And so it's a really good exercise. I'd recommend doing this again and again. Now, the next one is side, side, side. And so as you think about that, you don't know any angles, and there's an infinite number of triangles that can behave that way. That's how we can deal with similar types of triangles, is we know nothing about side, side. Oh, I'm sorry. With side, 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 apologize. I was thinking angle, angle, angle. But with side, 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 you don't know an angle in the side opposite, so it's got to be cosines. Cosines can handle that. I apologize for that. So you can see what cosine includes is maybe best just to memorize those. Cosine would include the given angle and side, side, side. So I apologize. Every time you're given a side, you'll be able to figure it out uniquely. It's just you need a side. So if you only had angles, it would just be a similar triangle. And then the last one, if we look at what's given for that one, what we're given is side B. We're given side C. And we're given angle A. Right, the angle in between them. So that's side, angle, side. And in particular, I don't know the side opposite my given angle, and I can't figure out the other two because I only have one angle. So this is cosines. And we're done, right, with that. So they'd like us to do this next one without the use of a calculator, find the measure of theta. And so let's take a look at this guy. This is example number 3, which is related to number 12 in the book. And so what we want is this angle right here. So let's investigate what the law of cosine says. The law of cosine says that if you want a particular angle, so let's suppose I called this angle A right here for lack of a better thing. What it's saying is that the side opposite it, 1 squared in this case, needs to be equal to the other two sides squared and added up, minus 2 times those exact same sides, right? So it's always these other sides. So it's the side opposite the angle, the sides adjacent are all in here. And then cosine of the angle that you care about. In this case, they call it theta. Okay, sorry about that. That's something on this screen. So let me get rid of those, but that's what we're solving. Now, you could take the time to solve for cosine theta first, but we don't need to. So again, side opposite squared is equal to the adjacent side squared minus 2 times those adjacent sides multiplied together, cosine. And so what do we have? We have 1 is equal to 1 plus 3 minus 2 root 3 cosine theta, or negative 3 is equal to negative 2 root 3 cosine theta, or what does that mean? It means cosine theta is equal to 3 over 2 root 3, positive, right? Because a negative divided by a negative, which is, if we rationalize, root 3 over 2. And they'd like us not to use a calculator. So they're saying we have this one memorized. It's obviously an acute angle because it's in a triangle. And so what cosine of what angle is root 3 over 2? That would be a 30-degree angle is what theta is equal to, just by memorization alone. So you're going to have some like in the last one where we have to solve the triangle. This is a side, side, side example. And so when we have side, 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 looking here at example number 4, what we want to do is make sure we solve for the biggest side first. So I'm going to make sure that we get the angle opposite that guy. So what are we going to do? We're going to say that c squared is equal to a squared plus b squared minus 2ab cosine of c. That's going to allow us to solve for that angle right there. Now, it's always best to solve for the biggest one, because if it's going to be over 90 degrees, we'll figure it out here. And so let's plug in what we need. Well, what's c squared? C squared is 10. is equal to a, which is 4 squared, and it doesn't matter what order you put these two in, minus 2 times 4 times 8 times cosine of this angle C. So that's 10 squared is equal to 16 plus 64 minus 64 cosine C. And that's 100 then is equal to 80 minus 64 cosine C. You can bring that over. 20 is equal to negative 64 cosine C. So cosine C is equal to negative 20 over 64. And we're not going to know that. So at this point, we might as well just use our calculator. So notice that it's negative, though. That's why you want to do the highest side first, because that negative is telling us that it's in the second quadrant, that this is an angle bigger than 90. And so let's go find it. So we're going to do our cosine inverse, and they want things in degrees. So we're going to make sure we're in degree mode. Cosine inverse, you don't even have to reduce it. Negative 20 divided by 64. And hit equals. And you're going to get that angle C is equal to 108.2 degrees. Now, what you don't want to do is do this lengthy process again. You're not locked into the law of cosines for everything. Once you've unlocked the first piece and know that this is 108.2 degrees, you can use the law of sines to unlock everything else. So what else do we need to solve for? I need angle A. So I know that sine A over 4 is equal to the sine of 108.2 degrees all over 10. And I'm going to use that. So what's sine A equal to? Sine of 108.2 degrees all over 10 times 4. Well, let's figure that out. Sine of 108.2 divided by 10 times 4 is a number, and we're going to take the sine inverse of that. That's also why you want to do that biggest side first, is because if you go to the law of sines will only put out angles in the first quadrant. And so what's A equal to? Let me tell you what I see sine A is equal to 0.379988. And so A is going to be the sine inverse of that answer. And we're going to get a nice 22.3 degrees. Okay, awesome. And then how are we going to figure out? So now we got C's angle measurement, A's angle measurement. We're going to use the law of sines again? That's crazy. We're going to take 180 degrees, subtract away 108.2 degrees, and subtract away 22.3 degrees. And go from that, 180 minus 108.2 minus 22.3. And you're going to get 49.5. And that's what angle B is equal to, is 49.5 degrees. So we could use the law of sines again, and we could have used the law of cosines, but we drastically reduce our work as we just keep applying those different pieces. You can see the length and the thought and the carefulness that needs to be applied there. A little bit less here and super simple here, right? And so we're just using all of our skills to go through. This would be something very similar to go through and do this number 34. So why don't we skip that since I don't have the room there. Let's look at, so that's what I mean by similar is that you're going to have to solve a triangle and you'll use the law of cosines to unlock one of the angles and then go from there. So let's take a look at the word problems that are going to be associated with this. So as you consider the word problems, we'll look at one and then we'll cut this video and go into the next. So we'll do this guy right here. Points X and Y are on opposite sides of a ravine. From a third point Z, the angle between the lines of X and Y is 37.7 degrees. So I'll just draw any old triangle here. X, Y, here's our third point that they're calling Z, and they're saying this sweeped out angle is 37.7 degrees. So getting a good picture will help us out a lot. From a point, okay, if xz, okay, is 153 meters long, and yz is 103 meters long, find xy. So as we do this finding the xy, we'll be doing that number 34 because that's what it was. It was a side angle side. If it was side angle, we would be using the law of sines. And so what we really want is this xy distance right here. No problem. I'm going to just call that little z. What we know from the law of cosines, and again, law of sines is not an option, we know that that z squared better be equal to 153 squared plus 103 squared. Don't worry if those are in different orders, doesn't matter. Minus 2 times 153 times 103, and then times the cosine of 37.7 degrees. Sorry, I squeezed that in there. So that's what we're going to be utilizing, the cosine of 37.7 degrees. Let me see if I can get that in here proper, and then come in here and erase. Well, we just run it in our calculator and we're done. This moment we find that, run that in our calculator, we will know the distance that they want. So what's z squared equal to? 153 squared plus 103 squared minus 2 times 153 times 103 times cosine of 37.7. And what do we get out of that? Well, we get a big number, 9080.2 ... But that's not what we want. We want the square root of that. So let's go get the square root of that answer, and we get a distance of 95.29 or 95.3, and everything was in meters. So the distance from x to y is 95.3 meters, something we couldn't measure because it's on opposite sides of a ravine. So what I'll do is end the video here and leave the remaining word problem examples to the next video. I'll make a part 2 just so they don't get too lengthy.